in this session, we are going to look a little into this thing called SVG. These are called scalable vector graphics. Now, this is an alternative to images, PNGs that you kind of use on websites, right? But why is it so very important? Now, the most important thing about why SVGs are important is that it's not defined by pixels. So if you take an image, for example, let's see if we can take out the icon here. Let's take out Google icon, right? So you will have different types of images there. And if you're going to look at something like this, right? And if you start zooming in, you can see that there is a pixel and there's a loss of clarity the moment you start to zoom in. Now, this is where SVGs come into play, where SVGs are not defined by pixels, right? So general rule with pixels, the more density you have, the higher quality it is. So pixels are nothing but it is actually it's built of so many square things, and each of it has like a color in that, and that's how this is being created for us, right? So that's what pixels do. Now those are what normally images and everything has. Now what when you say about vectors, right? It says there's a point here, right? There could be another point here, there could be another point here, and you are drawing a curve on these lines, right? So it's creating a curve based on some points in your on your system, and it's going to create another point here, and this is going to be like a rectangle here, and this is not going to be an image, but rather this curves on your computer, right? And we can fill this with some color. So now you're not caring about how big or small it is. You can create this at whatever size it is. So that's what you mean by vector. Vectors are basically something that can hold not just a value, but also like a direction. So we have these points in these systems, like you can think of a coordinate axis, and we can zoom in, zoom out, and we can get any kind of quality. So we get high quality images if you have an SVG, right? So if you were to use Google icon and say SVG, right? And let's just open this here, right? You can see that even though I zoom in, I don't really have a loss of quality as such, right? So SVGs essentially allow you to have high quality images without losing a lot of any kind of data. And softwares like Adobe Illustrator, all of these kind of work with SVGs to give you high quality output, right? So also in addition to this, when you're working with, let's say, images are one of the most reasons which contribute to size when it comes to loading a website. So if I'm not mistaken, around 70% of the site downloaded are for images. So you can significantly reduce the size requirements for an image if you actually use SVGs properly, right? So something which is of maybe 70, 80 KB can be brought down to maybe 5, 6 KB. And in addition to that, if you have an animation, if you're going to do with images, you generally end up having GIFs, or you create these images with frames, right? So which means it's an image after an image and after image. So those will end up being more expensive again, right? So that'll increase the cost for a website to be made or bundled. This also is where SVG can come in, and you can actually animate along with SVGs, and it will reduce the total requirement for your size. And at the same time, you get high quality outputs also. So here are a couple of reasons that you can use SVG as something. Right. One, you can animate them. to is low in size comparatively. There are some cases when you can get unnecessary complex shapes, which can create a lot of points and then increase size. So you wouldn't use in those cases, but in most cases, when it comes to a lot of simple shapes across the application, SVGs are much better. Another important cool feature is that you can actually style it. So you can actually apply CSS styles on some of the elements, and you can actually give it different colors, right? You can use JavaScript and actually interact with it. So those are some amazing things that we can actually achieve with SVG, which we may not be able to get with images. Another important thing is uh, resolution independent, right? We said earlier that it's scalable and it's vector graphics, right? It's resolution independent, and also we can contain it around a box. And when you kind of uh, change your screen size, etc., the SVG icons will also change accordingly. So you can say those are responsive also out of the box, right? So this makes SVGs very lucrative to understand, learn, and we're going to look into details of how to work with SVGs in today's session. So how do we work with SVGs? Now, SVGs come with a basic SVG tag, and you can create elements like rectangle, for example. You can use circles, for example, right? And you can draw out lines like this, for example. And you can create paths also along with SVGs, right? So in addition to that, you can also create one point like this, another point like this, another point, and then point like this, and then kind of join this. So this becomes like a polygon, right? So you can decide what kind of shapes you can use with SVG and create different outcomes based on that. Right, so let's go ahead and see how we can work with SVGs. So let's open this and yeah, so let's see how we can use the SVG element. So SVG is an attribute that you can use in your HTML pages, and you can apply some attributes to it, right? The first thing that you want to apply is the width that you want to apply it for. Let's say 400 pixels. Let's put a height of, let's say, 300 pixels, right? Then the next thing that you get is something called the view box. This is the minimum X, min Y, the width, and the height. Okay, so the view box is basically telling you what the size of the SVG box is going to be. So we said that SVGs are something like which are going to be responsive, and you can, it maintains aspect ratio and all of that. So the view box is what you will be working with to define the uh, the rectangle that SVG is going to work with. So let's assume this is the min X. Okay, min X comma min Y. This will be the width. This will be the height. Okay, so this will be min X plus height, comma min Y, because it's coordinate axis. Here it will be min X, or let's just call it X comma Y plus width. Okay, this is going to be X plus H comma Y, and this is going to be X plus H and Y plus width. Right, so this explains how the view box is going to be. Now let's say your actual height, let's assume, is let's say you put 0, 0, and let's put weight as 900 and then put 1200. And then let's say you design things inside this box, whatever you have, you start making things inside this, right? But you can see that we give a different width and a height. So what happens is the actual elements inside the SVG gets scaled down, right? So if you put something for 900 inside it, as height, let's assume some height is 900, it will become 900, 300 by 9 is basically 1 by 3, right? So in this case, it will be 1/3 that height. Right? So it maintains that aspect ratio. So it can be scaled down, it can be scaled up also. Right? This ensures that you get quality also maintained and it maintains the aspect ratio. So if you had something of, because we are going to scale this, in this case, it's going to be scaled by 3, scale down by 3 here. So if you had something of 9 pixels, it would become 3 pixels. Right? So this is how it's going to maintain that. So let's go create a simple element to see how we can visualize this. So we can create, let's say, rectangles here, and let's put 100, and let's put height is 100. Let's put fill and put black. Now, once you fill this here, you can see that it creates this rectangle box with us. It gives us this black color. So if you put different colors in it, it gives you different outputs. Right. So this is a small example of working or creating rectangles. Now you can also create like circles. Circles will have the center X position. So the center's position. So if you know how a circle is drawn, you'll have the Cx comma Cy here. So this is going to be Cx comma Cy. This defines where the position of the Cx and Cy is in the coordinate system. Right? And then it will also accept the radius for the circle. So here I can say Cx and Cy should be equal to 0. I can say radius should be, let's say, 70. Right? And if I say fill equals to black, right? And did we miss something? Cx, Cy. Oh, it's not radius, it's just R. Okay, my bad. So you can see that it creates this circle for us. If I made it 50, you will get in this manner. So let's go try to make this, put this inside this box here, right? So which means the center of these two boxes, the circle will be at 50 and Y will also be at 50. And if you do our radius 50, you can see that you inscribe a circle inside a square here. So if you made a different change, this is how it's going to look like. So you can go ahead and like play around with this and get different outputs here. Right? So all this does is create a rectangle, create a circle, and we get this kind of an output. So let's go try changing these values here, right? If I make this 200, right, and let's put 150 here. Oops, I've not put any values here, so I'm going to put 0, 0. Let's put 400 and 600 or 300, right? So you can see that the height, width, and the height are changing. So if I put this 400 and put this as 300, you can see that changes in this manner. If you were to put 500, you can see that the actual elements inside still maintain that size inside, right? The SVG itself may be having some change in the width, but our elements remain the same here. So this is how it's preserving the aspect ratio uh, within your web pages. So let's go and see if we can make a simple icon like Instagrams, right? I'm not saying we should have a exact perfect one, but let's go try to build something on these lines. Okay, so not looking for perfection, but at least a close similarity. So let's go create another SVG and let's put a square here in this case. Let's put something like 400 by 400. Right. So we'll need a couple of things. One, you can see that there is this outside um, pink voila thing there, which is giving you that. So let's go create that. Right. So let's call it a rectangle. Let's create 400, 400 over here. And let's fill it with, let's just keep a simple color pink. Okay. And let's keep this here. Okay. So we got this. So we can make this probably a little bigger. Right. So one thing you notice that the outside is a little curving, right? So how do we achieve that? Right? How do we achieve that as such? So for that, let's go ahead and add something called a CX, I think, or let's go see, right, rectangle, right? And you can, oh, it's called RX and RY, right? So it says horizontal corner radius of the rectangle defaults to RY specified, the vertical corner of the radius of the rectangle. So let's go add these two to your rectangle to create Rx equals to, let's put 40, right? And put Ry equals to 40. Let's see what happens. So you can see that you're able to get this changed. So if I make it something like 80, you can see that the horizontal one is changed. If I make it 80 here, you can see both of this has changed now. A bit similar to how you're working with CSS, but you're working with the SVG elements, right? So it looks like we have a basic outline there. If you want to make it 100, a little more larger, and you get that kind of outline. Now for the next part, let's go fill in the this box here, which is also similar to a rectangle, right? So let's go create a rectangle. But let's gonna create a little smaller one. Let's take a 300 something. I'm going to change this to white. I'm going to keep it pink itself, right? Let's keep this. So the X and the Y is going to change. So basically, I will need it to move some particular dimension ahead of it. So let's go draw this out and see what we're talking about. So we have this in line. We need another rectangle, which will give this kind of an output, right? So we basically need to determine what is this X and Y. So we're going to apply a bit of maths here. We know the total width is 400. This is 400 here. We know this is 300. We know this is 300. So let's assume this is X and this is X. If you want it on the same line, so we can see that 2X plus 300 equals to 400. So if we just do this, we'll get X as 50. So when we do X as 50 and Y as 50, right? If we do X and Y as 50, let's put this white for now. You can see that you get this kind of an output. Right, so I can just put everything in something that's more readable here. In addition to this, I don't want, because I don't want everything to be white. I want only the outline to be white. So I can actually put a stroke to be white. I can add a stroke width to be, say, 10, right? And let's change this to pink here. You can see that you get this kind of an output. So I can make this a little larger. You can see that you get this kind of a stroke, right? We can change this to a little smaller values, right? And we get something closer to what we want. We could probably do 70 or 75 also. Great. So we made two rectangles here, and we kind of gave it different radius, different colors. Stroke also we looked into basically to give it a stroke width, right? Let's go. What else do we need? You can see that there's another circle here, and there's two circles basically. So similar to how I made these rectangles, I can make a circle also. So let's go create a circle. I'm going to say Cx equals to, since I need the center point, right? I need it to be in the center. I know the SVG's view box is basically 400, 400, and we know the width and the height is 400 by 400. So I can say 200 by Cy equals to 200, right? And let's put 100 here. Let's put pink here, fill. Similar to what we did with stroke equals to white, right? And let's put this on the next line. Right, and let's put stroke width also here, and let's put 30. This is spelling missing. And you can see that we got something like this. We could probably do a smaller radius, so let's put 80, or maybe something smaller than that also. Right, so we get almost here and there similar. Now we need to have this position here, right? This circle here. So you can see that this is the width that it has, right? So this has to stay in this position. So how do we get that working? So let's go clear out some of this information here. Let's try to create that for our reference and try to calculate that output, right? So let's assume that we want something here, right? Which means this is the width that we add, that's W, let's say, right? This is also the width if you want consistency. We know this is 50, so X is already here, which is 50. So we know the position, the center position of one of them, one of the coordinates will be W plus X, which will be the Y here, right? Oops, W plus X, right? Now to get this whole length here, we know that this is the center position. From here, we need to basically get this whole length. So we can also just minus the W from there. So we can say 200 plus 100, which is 300, minus W. So I can create circle, and I can say Cx equals to, let's take what should be the value of W, right? So let's put CY, Y equals to something. And what else do we need? We need a radius. Let's put 20. And let's put fill equals to white. Or let's put, I guess, let's put 20 and see what happens, or 15 and see what happens. Now for CX and CY, we need to first decide what the width or W should be. So even to calculate the W, if you want very, if you want to calculate this, our radius for the circle here is 60, right? So this is already 60, right? So we actually have 40 as the total width. Now, if you do 40 divided by 2, we'll get 20, right? So we can try to see if 20 works. So let's do 300 minus 20, that's 280. And let's put 20 plus X, which is 50, so 70. In this case, there's something off definitely. We get in this manner. Let's see why that has happened. This is a stroke. So the stroke width, there's a 30 being added over there. So we may need to add this as 100. Yeah. So let's clear that out and see what happens, or just erase these elements there. Do we have any other strokes also happening internally? This is one stroke which is of 30 width. Yeah, I think one more issue is that this radius also has a stroke width of 30. So we can probably add 130 and kind of get that. So if I put 290 by 140 or 110, we get a similar structure, right? So the exact specifics can change here and there. So if I put 285, you can see that you get this kind of an output, right? So obviously there is a lot of, if you want to get exact specifics, you will need to kind of understand how to draw these geometries, right? And you need to know the width and height and kind of understand coordinate geometry. So if X and Y and those values you're able to calculate and figure out the positions, you kind of understand how SVGs are being positioned now, right? At least the most basic ones here, which is the rectangle circles shapes here. Right, so we easily made a simple Instagram icon. We do not apply any gradients or anything. That is something you can apply with a CSS. So if you apply a class to it, you can apply values into that. So the next thing we are going to look at is working with polygons, right? So we can make shapes like triangles or squares or pentagons or etc. on those lines, right? So I'm going to create an SVG file here or SVG here. I'm going to create something 100 here. I'm going to create the view box as 0, 0, 600 and 300 here. So I can use a polygon here in this manner. Now, the things that the polygon will accept are something called points. Okay. And let's also do a fill black. Now, let's draw this out and figure out how. So when you have something like 600 by 300 here, if you wanted a triangle, right? If you wanted a triangle, let's say you wanted to create something like this, right? So this is 0. Let's put this as, I don't know, 100, comma 0. Let's put this as 100, comma 300, right? And let's put this as 0, comma 300. So these are the points that we get. So if you want to think about it, P1, P2, and P3. So each will have its own X and Y, and we can create from that. So if I put 100, 0, or I can say 100, comma 0, and then I can say 0, comma 200, and I can say 100, comma 200. And now if you refresh, you get a triangle in this manner. Now, instead of putting 100, comma 200, if I put 200, comma 200, I'll get a little larger triangle. Right? So this is how you can create polygons. And if you want to create more elements, so let's try to see, in this case, I basically created a triangle in this manner with 200 here. Now, if you wanted one more point here to make a parallelogram, let's say, we basically have 300, comma 0 here. So if I put 300, comma 0, you can see that we get a parallelogram, right? So these points are just coordinates of each point that you need, right? And if you put different colors, you get uh, that output accordingly, right? And you can see that you can zoom in, and it looks pretty clear even after that, right? So the quality is being maintained also as well. Makes sense. So this is how you work with polygons. And now you can also like put, depending on the position of when the element is, you can start to create more complex objects also in your, when you work with SVG. So if you want something behind something, you want to ensure that this comes after that in SVG. So you might want to define this first and then create this after that, right? So let's look at more things over here. And let's look at the next element called path. Yep. So I'm just going to say this is polygon, right? These were rectangle and circle. This is for histogram, and this is for rectangle and circle. So let's look at paths. Now, we mentioned earlier that we are able to draw out curves, right, on those lines, or even just like create lines or etc. So this is also possible. You can actually create lines directly using when you're working with SVG. So if I just line SVG. So let's put that here. Yeah, so you get this line here in this manner. So there's also an basic element that you can use. So if you say width 200, height 100, view box as 200, 200, 100, you can put a line, right? And you can put x1, x2, and y1, y2 to create this. So if I put x1 equals to 20, y1 equals to 20, and say x2 equals to 200 and y2 equals to this is y1. I can say stroke equals to black. Now, if I do this, you can see that it creates a line. Now I can also make it slant just by changing the y2 here. For example, if I put y2 is 40, you can see that the points are basically changing and you are just creating a line between them. Okay, so this is how you use lines. But sometimes you want to create something more complex, right? Maybe you want to create something like you want to create a curve like this, or maybe you want to create, let's say, um, a leaf in this manner, let's say, right? Or you want to create a bell in this manner, right? So using these, so these are a little more complex things that we can use, and we use something called paths for that. So if I wrote path, right, you can use path in SVGs, right? And it takes a few commands along with this. So it accepts something called D, which means to draw, right? And then you can pass a lot of values in that. I'm just going to put stroke is black. And for now, I'm just going to remove the fill. I'm just going to keep it as none for now. Yep. So we don't have anything. So the first command that you want to work with when you're working with these, that there is a M command, which means basically you need to move it. Right. So M X comma Y basically is telling where to move it to. So capital M is an absolute position. Or if you do M, it's small m, it's a relative path. So if I can put M00, right, it'll move to that position, but it doesn't really draw anything at that point. Okay. So for drawing, you can use L, capital L or small l. So L, again, capital L will tell you that it is um, it's a absolute positioning, while small l will tell you that it is a relative position. So let's go and make L10, 10 comma or 20 comma 20, and then let's put 200 comma 20 also, right? And you can see that this has basically moved to 0 0, right? And then from there we have drawn to L2020, and then we have drawn L220. So this is basically creating that path for you. Right. So if you didn't want that first 2020, so I can just go ahead and create 2020 in this manner. So this will ensure that you move it in this direction. Now, let's say you didn't know the absolute position, etc. So we can actually put the lower case, and we can, let's say, move it 0 in this direction, and let's put 50 downwards. You can see that you're able to draw something more late, because we may not remember how the position is absolute values, right? Because once you get a point, you might think only relative, because we say move to this position, move 50 to the right, move 50 down, and then kind of figure that part out, right? So if you want to close this up, you just need to write L. I can put minus 200 and say 50. Oops, or since it's relative, I can just say 0. right? This is 180 because we are not going to 100. And I can just say L, and I can bring up 0 and then do minus 30 or minus 57, right? So we just drew out a rectangle in this case. So when you're working with paths, we right now saw just two, three things, which is move. We use the L command, capital and small l. There are other ones also, for example, like drawing a horizontal line, vertical line, etc. Okay. Now, what we can also look at are other things where we can create curves. Now, in the previous session, you would have we spoke something about Bezier curves, right? Which are nothing but you have 2 points, and you can define the amplitude or something towards one direction, the amplitude to another direction, and this will create a curve for you in this manner. So these are Bezier curves, right? So you can use actually Bezier curves also for your application, which basically says x1, y1, x2, y2, and then how far do you want to, like the relative changes also along. There are absolute changes. So there are a lot of examples here also on how these paths work. So let's go also see a simple example. Let's create another path, right? And I'm just going to say m. Let's put 70, 20, right? And let's put fill equals to none and put stroke equals to black. Right, and let's try to create a simple one on one of these lines here. Okay. So we just moved it, we don't have any outputs. So it says C x1, x2, x1, y1, and then x2, y2, and then x comma y. So let's go try what we can do with this, right? So let's go see here. We're able to create something on this side. So let's assume this is the point here. Let's say we want to create another point over here. This is our absolute x, y there, right? This is our initial position. We are already there because we moved to that position. Now, if I want something in this manner, this amplitude here, and we want a curve in this manner, right? In this manner here, right? So we can create that by writing C, there's a capital C here. And I am just going to say, so we have 70. I'm just going to add like 50 to it, saying in this manner. Did they use commas? Yeah, so you can put comma after this and say this is going to be 200. Okay, this is going to be 20 and 70. 120. And I'm just going to say 220 and 120. Right, and I'm going to say the final x comma y is going to be 220 and 70. Right. Oops. We may be out of the size view box here, so I'm just going to say 400. Right, and I'm going to say 400 here. We'll need a little more size here, so I'm going to say 400. So there seems to be a small change. Maybe this is 200, not 220. Right. This also is going to be 200. Great. So we can see that we actually made this small thing over here. Right now, if you wanted this to be a little more, we basically need to increase our amplitudes. So here, this represents these values here, right? This is one here, this point here. This represents, this is two here. It represents this point here. This represents the final point over here, which is 3. Okay. So if we just change the amplitude here to 1, let's put 200, you can see that we are able to pull that depth down by just pulling that control points. Okay. So this is how you can work with paths, and we can get more complex ones also out there. So you can see how different paths or different curves can be generated by having these control points in this manner here. Right, the control. So you can see the last set of the cubic curve. It has 2 control points for each point. To create the cubic Bezier, the set of coordinates need to be specified. Right, this is the x comma y is where the line should end. The other 2 are the control points, which we just defined there. This essentially describes the slope of the line starting point at each point. So what it's basically doing is that once you define these 2 points, right? Once you define point 1 and point 2, it's saying that, hey, this curve should be, let's put another point here. This should have like a tangent to this, and also at the same time be a bit tangential to this also. Right, and then you should join these 2 as such. So it defines how much it should be basically pulling it out as such. Now, the cubic Bezier curves actually give you a lot of control on how to work with it. There are other ways to also work with it. I'm going to pick out one of those things, and that's called the Q. I think it's called the portrait, is it? I can't remember what the name was for Q. Doesn't seem like a Q. Doesn't seem like there's a name. It's called a quadratic curve, yes. So we can use a Q also. This is a little more simpler to work with sometimes. Although the cubic Bezier gives you a lot more control, sometimes Q, if you use quadratic curve, it's a lot more simpler to work with it. The main reason is that you have only one control point, not multiple control points, right? The other place we had 2 control points, which was this and this here, which defined how the curve will become. But in this case, we have 1 point here, final point here, and this is the final Q, or the control point, which is defining the curve. So instead of this, if I just go ahead and change this, right? And if I used Q instead, right, and let's Q there, this is the final point which we need. I can define some line between, which says, let's say 100 comma 120, right? So what it kind of creates is this single point here, right? A single point, which is creating this tangent towards this, and then another tangent here. And that's how it creates that curve there. So this is how, when you're working with, if you work with geometry, right? I guess some bisectors or something like that, you might end up creating these 2 lines in this manner and kind of create these curves around it. This is, you would have probably seen this more often than not if you have worked on any kind of coordinate systems or machine drawing, We generally call it computer-aided machine drawing as such when it comes to generally the fields of mechanical, electrical, civil, all these lines. But end of the day, how those lines are being projected onto that software uh, is by these splines or these curves that is being generated here. So any kind of manufacturing, any kind of like design systems out there which um, uses lines, it follows this logic here about how to create those curves. Great. So we so far looked into um, working with polygons, right? We also looked at creating custom paths. This is very cool, very interesting to learn also, because this explains how a lot of the paths work, and you're able to create your own custom paths. And we were able to figure out and play around with this. Now, we'll also work with another tool which can create these files for us also. Before we finish, I also want to show one more thing with paths. So if I actually fill, let's say, with some pink color, let's say, right, it creates this in this manner for us. Now, if you ever finish something with Z, right, you will see that this small black line which came there. So let's go and comment this out, right? So if I remove this Z, it doesn't close that particular box. If you want to close it, you just write an Z to the last section saying that, hey, this indicates that you need to close this. So it'll ensure that the path is closed. If you remove the Z, it won't. By just adding an Z, it closes that for you. Right. So if you want to complete a path, just write an Z right after it. Great. So this explains a lot to work with SVGs. Now let's also figure out one of the tools that we can actually use to work with SVGs. Now, I want to take one more example before we move to Figma or any other tool that we like a design tool for this. So let's write that down. Okay. So you would have noticed there are some tools or some images or some UI out there which uh, has like, let's say, some element inside it, and this keeps on moving, or you have some kind of transition or some animation on top of this, right? So you would have different layers moving at different speeds, right? So these effects can also be achieved with SVGs. Now, how are we going to do this? We're going to first create an SVG again, and let's see from there. Okay, so let's take a circle. Let's put 200, CY is 200, R equals to, let's say, 100. And let's put a fill of pink, right? And we get this here. So let's create like similar to a polygon. Let's create a polyline. This can be a path also. So we can make a path also, not a problem. But a polyline is similar to a polygon, but we just create lines basically. Right. So let's go and create points here, right? So let's put it at 100, 100. Let's put 200 and 200. Let's just see what that happens. So let's put stroke equals to black. Width equals, let's put 10, right? And let's create this. So it kind of creates something in this lines. So let's just put in this manner, create. Okay. So let's put something like this, right? And let's go ahead and create a little more few elements around this. So let's make this 150, 150. Let's put 200, 200, right? And let's put fill equals to none, right? And let's keep a few more elements within this. So it's 250, 150, 300, 200, and let's put 350, 150, and 400, 200. Right? It creates something like this for you now. But you can see that this is basically going outside this, right? And I can apply a transition and basically move. But how do we ensure that we don't see anything beyond this shape here, right? How do we ensure that happens? So over here, we can use something called a clip path. So we can create an element called clip path. Okay. We can just give it in some ID for it. Let's say circle or something, right? And I can create this inside it. This doesn't matter. Now what I'm saying is that there's going to be another circle where I'm going to clip this path and I'm going to create a ID around it. Now I can give that as an argument saying here clip path, and I am just going to select that element of the ID from there. So I can pass a URL into this and say circle over there. Once I do this, this should be hyphen path, I guess. You can see that you are able to clip it. So can I apply a style into this, which actually animates this for us? Right. So let's go add a style into this, which creates this transition effect, let's say. So let's put a simple thing saying now to get this to work, we need to make a few changes so that we can apply the transition effects and all. So let's go first create a simple style here, right? And let's create a class called move waves, move waves, right? And within this, let's create an animation and let's say move. Let's put 2 seconds. Let's put linear and infinite. So let's create a keyframe, right? And let's create a move. And let's create a from for it and say transform translate. Let's just say we bring it from -100 pixels to, and I say transform translate and put 0 pixels there. Okay. And I also guess each of this is 1550. So when it moves from 100 pixels, it completes uh, one width or a triangle at least. So let's go add our class to it, and let's say move waves. And you will start to see an issue that the clip path that we applied is no more working. So for this to work, let's go create a group. Okay, G means it's a group. Okay, this is just a group that we can have, and we can apply the clip path on the parent over here, and we can get it to work. Right. So this is basically creating our element, and we are able to see this animation in this wave format within this, right? All we have kind of done is write this simple polyline. We're able to write this. Now, let's say we wanted multiple polylines, right? You might think that, oh, I have to sit and create this over and over again and kind of modify these values, right? So that becomes very tough to work with. So you can actually create something called definitions uh, for your tags, which you can use at a later point, right? And instead of this, I can just say use, and I can say, I can put an ID on this saying path wave, and I can use a use tag here and say path wave. I can put X and Y over here. Right, and apply this, and we get a similar output. But now, if I were to make some changes saying, hey, I want one more, instead of 0, I'll just put a Y as 50. You can see that now we get 2 of those elements, right? So we reuse this polyline, and we were just modifying the relative position along with that. So everything remains the same except the relative position there. So we were able to use this in a pretty good sense, and we're able to create this kind of a pattern within your SVG, right? And this costs nothing for your for with respect to KBs or size for your website, right? All you can see is that these are the SVG tags, and this is the only style that is actually being applied to it. Great. Just to reiterate what all we have covered so far in this session, we started to work with basics of rectangle and circle. We did an example of trying to work with an Instagram example, and we were able to make that. We moved to a little larger example of using polygons and creating triangles and parallelograms, and you can kind of create any polygon basically, right? After that, we looked at path as an example. We looked at line, creating lines, slanted lines. We looked at paths as an example. We looked at moving. We use the L command, the capital L and the small l. Small l uh, refers to the change or relative path or relative drawing a line. We also looked at cubic Bezier curves here. We looked at um, using Q or the quadratic curves here, right, which is a little more easier, or we have one control point, while in in cubic Bezier, we have 2 control points basically. After that, we looked at how to clip a path, and we were able to contain it within a particular circle, which we created here. And on top of that, we created a background here. We used or created a polyline for it, and kind of used an animation on top of it. But we used a group for that because when you applied the animation, the clip path wasn't working. So we applied that clip path to the parent. What happens is, I'm guessing, is that when you apply animation, the z index changes and it pushes the element out of that. So we create a group and apply that clip path to the parent. And from here, we were able to create these definitions, and we created the definition for this polyline with an ID. We were able to reuse this polyline for multiple things, and we kind of changed is the X and the Y coordinates, and we were able to get exact copies replicas. So this helps when you want multiple values or multiple elements within your SVG, right? And you don't have to manually sit and write those. So you create one polyline and we can reuse it like a variable, how we use it in programming languages. So actually, we're going to take a stop here and we'll discuss other tools we can work with, like Figma or anything in the next session. We're going to look at Canvas and we're going to look at a bit of Figma as a design tool towards the end of it. And we'll work with a bit of JavaScript and understand how to make some animations using JavaScript and along with these elements that we looked at so far.